In the vast tapestry of existence, where light and time weave the story of everything, a single truth hums beneath it all. The universe is not just a place, but a process, an unfolding symphony of creation where every note is a star, every chord a galaxy, and every silence a mystery waiting to be heard. The wait is over. The James Webb Space Telescope, humanity's most audacious eye on the cosmos, has unveiled an image that is not merely a photograph, but a revelation. This is no ordinary glimpse into the heavens. It is the deepest, most intricate portrait of the universe ever captured. A single frame holding the light of billions of years. A canvas painted with the birth cries of stars and the whispers of worlds long gone. This image, released after years of anticipation, is a window into the very first chapters of cosmic history. A view so profound it challenges the boundaries of what we believe is possible. In this video, we will journey through this extraordinary image, unravel its secrets, and grapple with what it means for our place in the grand cosmic narrative. This is not just a picture, it is a revolution in our understanding of existence itself. What are we looking at? Imagine a patch of sky no larger than a grain of sand held at arm's length. Now imagine that within this infinitesimal speck, the universe has hidden a story spanning nearly 14 billion years. This is the James Webb Space Telescope's deepest image yet, a masterpiece born from its unparalleled ability to peer into the infrared spectrum, where the oldest light lingers. Unlike any telescope before it, this instrument captures the stretched, reddened glow of the universe's infancy, light that has traveled so long it carries the memory of the first stars. This image is not a single snapshot, but a mosaic, painstakingly crafted from thousands of exposures, each one a delicate sip of ancient photons. The result is a view that spans millions of light years, revealing a staggering density of galaxies, hundreds of thousands, each a metropolis of stars, gas, and dust, stretching back to the edge of the observable universe. This is not just a deep field, it is the deepest field, a cosmic archive that holds clues to the birth of everything we know. To grasp the scale of this achievement, consider the telescope itself, a marvel of human ingenuity perched at the edge of what's possible. Its golden mirror, a 6.5-meter mosaic of 18 hexagonal segments, gleams like a beacon in the void. Each segment, crafted from beryllium and coated in a whisper-thin layer of gold, is designed to capture the faintest infrared whispers from the dawn of time. But light alone is not enough. To see the universe's earliest moments, the telescope must be colder than the void itself, chilled to a mere 50 degrees above absolute zero. A sunshield, vast as a tennis court, yet delicate as a spider's web, blocks the searing heat of the sun, earth, and moon, creating a sanctuary of frigid darkness. Within this icy haven, the telescope's instruments, its near-infrared camera and mid-infrared instrument, work in harmony, peeling back layers of cosmic history. The near-infrared camera paints the backbone of this image with crystalline clarity, while the mid-infrared instrument pierces through veils of dust, revealing hidden nurseries where stars are born. This is not just technology. It is a triumph of human will, a machine that lets us read the universe's oldest poetry. What does this image reveal? The first shock is its sheer abundance. Galaxies, far more numerous than any model predicted, crowd the frame like stars in a desert sky. Some are spirals, elegant and familiar, their arms curling like cosmic dancers. Others are irregular, chaotic smudges of light, caught in the act of colliding and merging in the universe's wild youth. But the true revelation lies in their age. Many of these galaxies shimmer with light that left them just 200 to 300 million years after the Big Bang, a time when the universe was thought to be a dark, formless void. According to the standard story, the cosmos began 13.8 billion years ago in a blaze of light and energy, followed by the cosmic dark ages, a period when neutral hydrogen cloaked the universe, smothering the light of the first stars. Only slowly, over hundreds of millions of years, were these first stars and galaxies supposed to ignite, burning away the fog in a process called reionization. Yet this image tells a different story. It shows galaxies that are too bright, too formed, too early. It's as if the universe was already alive and thriving when it should have been a newborn, barely stirring. This unexpected vibrancy demands a closer look. Among the galaxies in this image, astronomers have spotted something extraordinary: compact, dense clusters of stars that defy our understanding of cosmic evolution. These are not the sprawling galaxies we know today, but proto-structures, the embryonic seeds of the great star cities like our Milky Way. Some of these clusters, observed just 400 million years after the Big Bang, are so massive and tightly packed that they resemble the globular clusters orbiting our galaxy today. These ancient relics, found in a distant galaxy seen in its infancy, suggest that the building blocks of the universe's grand architecture were laid down far earlier than we imagined. It's a humbling discovery. The Milky Way, with its 100 billion stars and intricate spiral arms, is not a latecomer to the cosmic stage, but the heir to processes that began in the universe's first breaths. These clusters are like fossils, preserved in the amber of ancient light, offering a direct glimpse into the machinery that built the cosmos. But the surprises don't end there. This image has also captured something once thought impossible: the light of individual stars, blazing across billions of light years. This feat relies on a phenomenon predicted by Einstein himself: gravitational lensing. When a massive object, like a galaxy cluster, sits between us and a distant star, its gravity warps space-time, bending and magnifying the star's light like a cosmic lens. In this image, astronomers have identified stars amplified thousands of times, their light stretched across vast arcs in the sky. One such star, seen as it was 12.9 billion years ago, is the most distant ever detected, a solitary beacon from a time when the universe was a mere fraction of its current age. This is not just a record-breaking observation. It is a bridge to the past, allowing us to study the chemistry and behavior of stars that burned when the universe was young. These magnified stars also reveal the invisible: the distribution of dark matter in the lensing clusters, a substance that outweighs all visible matter and shapes the universe's structure. Each star is a clue, a key to unlocking the mysteries of both light and shadow. The depth of this image extends beyond its scientific revelations to the very process of discovery. The data behind it, every pixel, every spectrum, every measurement, has been made freely available to the world. This is not a treasure hoarded by a select few, but a gift to humanity. An interactive viewer allows anyone, from a seasoned astrophysicist to a curious dreamer, to explore this cosmic landscape. The raw data, once a labyrinth of complexity, has been transformed into a science-ready catalogue, a map that invites exploration. This democratization of knowledge is a revolution in itself. For centuries, the universe's secrets were locked behind the gates of observatories and institutions. Now, they are open to all. A student with a laptop, a researcher with a hypothesis, or a citizen with a spark of curiosity can dive into this data, asking questions that might reshape our understanding of the cosmos. This is not just science, it is a shared journey, a collective quest to know the unknown. What does this image mean for the future? It is not the end of a story, but the opening of 1,000 new chapters. The James Webb Space Telescope continues to gather light, pushing deeper into the universe's past with every passing day. Each new observation builds on this one, adding detail to a picture that is still coming into focus. The galaxies in this image are not static. They are snapshots of a universe in motion, a cosmos that has been evolving for billions of years and will continue to do so long after we are gone. The questions raised here about the timing of galaxy formation, the nature of dark matter, the origins of stars, are not answers, but invitations. They beckon us to keep looking, to keep asking, to keep building tools that let us see farther. The universe is not a puzzle to be solved, but a story to be told. And this image is one of its most vivid pages yet. To stand before this image is to feel the weight of time itself. Every galaxy, every star, every photon has traveled billions of years to reach us, carrying the story of a universe that began in a single, incomprehensible moment. Yet this image does more than show us the past. It reframes our present. In a patch of sky so small we could blot it out with a fingertip, there are hundreds of thousands of galaxies, each home to billions of stars, each star potentially orbited by worlds we cannot yet imagine. Our planet, our home, is but one speck in this vast cosmic sea, orbiting one star among countless trillions. This could make us feel small, insignificant, a fleeting whisper in an eternal chorus. But it doesn't. Instead, it fills us with wonder. The same laws that forged those distant galaxies govern the atoms in our bodies. The same light that illuminates this image flows through our eyes. We are not separate from the universe, but part of it, a fleeting but vital expression of its endless creativity. This image is a mirror. It reflects not just the universe, but our capacity to understand it. From the earliest humans who gazed at the stars to the engineers who built this telescope, we have always been driven by a hunger to know more. This image is a testament to that hunger, a reminder that our questions are as vast as the cosmos itself. It challenges us to think bigger, to dream deeper, to reach further. The universe is not a distant spectacle, but a living story, and we are its storytellers. With every new image, every new discovery, we write another line, another verse, another chapter. This is not the end of the journey, but a beginning. The cosmos is calling, and with this telescope, we are finally learning to answer. As we move forward, the data from this image will fuel discoveries for decades. Scientists will pore over its details, uncovering new truths about the universe's birth, its growth, its hidden corners. But the true power of this image lies not just in what it shows, but in what it inspires. It reminds us that the universe is not a finished work, but a process, one we are privileged to witness. It invites us to keep exploring, to keep questioning, to keep marveling at the beauty and complexity of it all. This is not just a picture of the universe, it is a picture of possibility, a vision of what we can achieve when we dare to look beyond the horizon. The stars are not just out there, they are within us, urging us to reach, to wonder, to understand. And with this image, we are one step closer to knowing who we are, where we came from, and where we might yet go.